Alright, so 3.1, solving two-step equations. I'm going to give you the methods to solving equations. Okay. Goal is the same every time. Your goal when you're solving is to get the variable by itself. Now, when we start with one step and two step, it's really easy to figure out what the answer is, but I don't care about the answer right now, and I'm going to be very picky about the process. We're learning the process of solving equations, okay? So that is your goal. Your goal is to get the variable by itself. When you get the variable by itself, answer will appear, okay? So step one, you're going to find something being added or subtracted. Once you find that something's being added or subtracted to the variable, what you're going to do is you're going to do the opposite. So if it's plus 3, you're going to subtract 3. If it's subtract 5, you're going to add 5. We're going to do the opposite to both sides. And both sides means to the both sides of the equal sign. Both sides of the equal sign. Okay? That's step one. Now, if there's nothing that's being added or subtracted, then you're going to move on to step 2. So we're going to go down the line of our reverse order of operation. Yep. Okay. So if you did this already, and then if x is not by itself, then you must go to step 2. Okay. And step 2 is to find something that's being multiplied or divided. Okay. Multiplied or divided. And you're going to do the same thing. Do the opposite to both sides. Thank you, sir. Okay. And if there's nothing that's being added or subtracted or multiplied, divided, then you just go down the line of the reverse order of operation, and you're just going to keep looking for things to do. Okay? So, right now, we're doing 2 steps, so this I'm just going to leave it at this for now. All right? And I'm going to give you an example. I'm going to start with easy, one-step problem. And you'll see why it's called one step. You're only going to require either this one or this one. All right? Not 2.
There's only 2 steps.
Okay? So one step. I'm going to ask you to solve. So when I ask you to solve, you're solving for x. So you got -4 equals x plus 4.
You want to select actually like...
Do we know the answer already?
No.
Nash, what is it?
I don't know.
You don't know?
I know.
Yeah, Jackson.
It's -8 equals x.
Yeah, x is equal to -8. Now let's prove it. So now we know the answer, right? We know what it should be, but I don't care what the answer is right now. I want to teach you the process, okay? So we're going to draw the dashed line through the equal sign. Remember, your goal is to get this x by itself. That means you look at the side where the variable is, and you're going to look to see if something's being added or subtracted. So, Autumn, what's being added or subtracted?
It's like plus 4.
Yeah, it's plus 4.
Yes.
So, what's the opposite?
You have to subtract.
Thank you. So, you're going to subtract 4. Remember, we do it to both sides of the equal sign. Right?
Haven't we done this before?
Yep. So then, please do this though. Does 4 minus 4 take away that 4 from the x side of the x?
Yes.
Yeah. So, now don't put the 0 down here.
0
Put it up here. What you're going to put down here is what's left. What's left on this side of the equal sign? X. So you x, because x plus 0 is just x. That's what's left. That equals, what's negative 4 minus 4? Negative 8. See how the answer just popped up? That's why we want to get x by itself. Okay? That's how you do it. You do the opposite of what's being done to the x. Let me give you another example. Ready? I got x over 5 is equal to 30. Now, we're going to go back to step 1. Is something being added or subtracted? No.
It's division.
So then you go to step 2 and say, okay, is something being multiplied or divided? Divided. This means to divide. I want to get this by itself. So since it's being divided by 5, what's opposite of dividing by 5? Multiplying by 5. So this is how I want you to write it. Multiply by 5 like this and put it up here like this. I don't want you doing this. That is wrong. That means you're just multiplying the denominator by 5. Okay? We're going to put it up here like this, and since this is a fraction, we're going to make that a fraction. I mean, we're going to do it to both sides of the equal sign. I'm going to multiply that by 5. What happens to my 5s over here? They cancel out. 5 goes into 5 how many times? Once. Put a 1 up here. What's 1 times x? X. Is x by itself? Yes, it is. And what does that equal? What's 30 times 5? 150. Right? 5 times 0 is 0. 3 times 5 is 15. Answer just pops up when you do the process. Okay? And I want it just like this. I'm going to be very picky about how I grade this. Okay? So ready for 2-step?
Yes.
Okay. No? Who said no?
I'm ready.
You ready? All right, here's 2-step. So this is example number 1 in your book. 2-step. Can you see it? There we go. It's going to say solve, and it's going to ask you to check. So we're going to do both. Solve and check. Solve for the variable, solve the equation, and we're going to check. Here we go. Ready? 13 is equal to x over 3 plus 5. Anybody know what the answer could be? What can be the x? Anybody know?
1.
Without doing the process.
Wouldn't it be 1?
No?
Oh.
Well, then let's solve. Here we go. Ready? Draw that line. Go to the variable side. Remember, step 1 is to find something that's added or subtracted.
They're divided. Well, they are added.
What
too.
is being added or subtracted?
Plus 5.
Plus 5. What's opposite of plus 5?
Minus 5.
So we're going to minus 5 to both sides. Now put it under the like terms, please. Do not put minus 5 over x over 3. Put it under here. Draw that line. 5 minus 5 is? 0. So did I get rid of that?
Yeah.
I'm almost there. X is almost by itself. Not quite yet. But we got to take it one step at a time. So this would be x over 3 is equal to 13 minus 5 is 12. Okay? That was step 1. Yes, sir.
I was just going to answer the
Okay.
13 minus 5.
So now, 13 minus 5. Oh, sorry. My bad. What is it? 8. Thank you.
I was so
That's why you guys are here. Right? So now, x is being divided by 3. So, Will, what do I have to do? Multiply by 3. So remember, put that parentheses there. This is multiply by 3. Multiply by 3. I'm going to put this over 1. Does 3's cancel out?
Yes.
Yeah, that's the goal, right? We want to get rid of stuff away from x. 1 times x is x equals 8 times 3 is 24. And the answer just pops right out when you do the process. Okay? Now here's how you check. We're checking to see if this side of the equal sign is equal to this side of the equal sign. That's what you're checking for. So you start with the original. And I want to know if this is equal to this when I plug it in, right? X is equal to 24, so now let's plug it in. When I plug it in, is this side going to equal 13? Is this? So what's 24 divided by 3? 8. 8 plus 5 is? 13. So does 13 equal 13? Do they equal? Yeah. So that means you got it correct. The reason why we check is to see if your answer makes this true. Okay? Now, just because you did this process, don't just say check, because sometimes it might not check. I have students just do that for me because I told them to check and they had to do it. They just found the answer. It was wrong, but they went through and made it equal. I don't know how. Okay? Any questions so far? So far, so good? All right, ready for this one? This is a doozy. Solve and check. Ready? X plus 6 divided by 4 equals negative 7. Addison, do you know what we should do first?
Alright, hold on, I'm sorry. I don't know.
The first thing you would do would be to subtract the 6.
Because I said those were my steps, right?
Yeah.
Anybody else agree with that?
Well, don't we have to put the line here or something?
Yeah, we do that, but can I take that 6 away?
Yeah.
Can I?
Yeah.
Not yet.
Not
You
yet.
have to
I have to do what?
multiply
Why?
because it's
Because it's being
different. It's
divided.
the other version of division.
Right here, right?
Yeah.
This is more than one term. There's an imaginary parentheses there. Because what it's saying is, this is telling me to add 6 first and then divide. So there, if you're going to add, because order of operation normally is addition, right, before multiplication or division. But this is telling me to add first. The only way to add first if there was a parentheses. So there's an imaginary parentheses. So now, using the reverse order of operation, remember parentheses last. So I can't touch this until this is gone right here. So Nash says this is being divided, so I'm going to multiply the whole thing, or I guess I could just come over here. I could leave it like this and say multiply by 4. So then I'm going to multiply that by 4. Now if I put this over 1, what happens to my 4s?
They cancel.
They cancel out. And that's what we wanted, right? We wanted that to go away, right? 1 times x plus 6 is just x plus 6. It's whatever is left on that side is what you keep, because we're getting rid of stuff on the variable side, right? Because we want to get x by itself. So then, now, Addison says we subtract 6, right? Because now there's nothing else to do but to subtract, right? To get x by itself, we're going to subtract 6 to both sides. And then x is by itself because x plus 0 is just x, and x is equal to negative 34. This is a process we must learn how to do because our equations later on is going to get much more difficult than this. Now, how do we check?
Plug in the same thing.
Write down the original. And we're checking to see when I plug in negative 34, is it going to equal negative 7? That's what you're checking for, right? So we're going to plug in negative 34 plus 6 divided by 4. Is it going to equal negative 7?
Yes.
What's negative 34 plus 6?
Negative 28.
Negative 28. And what's negative 28 divided by 4? Negative 7. So yes, it does equal negative 7, so it checks. So everybody understand how to check? Okay?